Kinematics. Kinematics is motion in a straight line. Today we are going to begin by learning the displacement function, or the position of an object. An object P moves along a straight line so that its position S from an origin O is given as some function of time t. S is equal to S of t, where t is greater than 0. This is the diagram that you will use when writing a displacement function so that you know how far the object is from the origin. When you are trying to interpret signs of a displacement function, when P is located to the right of the origin, the displacement function is going to be larger than 0. If P is located at the origin, the displacement function is going to be equal to 0. If P is located to the left of the origin, the displacement function will be less than 0. Whenever you see the words initial conditions, remember that t is equal to 0. When looking at a motion graph of an object and trying to determine where its position is for different times, this is how you would graph it. Consider the function shown before you. S of t is equal to t squared plus 5t minus 8 centimeters. To determine the position of the object, you would plug t in for whatever time you are given, such as 0, 1, 2, 3, and 4, and then graph it onto the motion graph. To appreciate the motion of P, we draw a motion graph. From this, you can also see what is happening to the velocity and acceleration.
Velocity. Velocity can be found by taking the derivative of the position function. Average velocity is the ratio of change in displacement in the time taken. S of t sub 2 minus t sub 1 over t sub 2 minus t sub 1. Velocity can be equals to the derivative of the position function equals to limit as h approaches 0, s sub t plus h minus s sub t over h. This is the instantaneous velocity of the object at time t. Velocity equals 0, object is instantaneously at rest. This is when the object changes direction. V sub t is bigger than 0, object is moving to the right. V sub t is less than 0, object is moving to the left. Acceleration can be found by taking the derivative of the velocity function. The average acceleration is the ratio of change in velocity to the time taken. Average velocity v of t sub 2 minus v of t sub 1 over t sub 2 minus t sub 1. This is the instantaneous acceleration at time t. It can be found by limit as h approaches 0, v of t plus h minus v of t over h. The units of velocity are ms sub negative 1 to the power of negative 1. Units of acceleration are ms to the power of negative 2. Acceleration equals 0, the velocity is at its maximum, minimum, or its constant. Acceleration is bigger than 0, the velocity is increasing. Acceleration is smaller than 0, velocity is decreasing.
Speed. Speed is the magnitude of the object's velocity. When the speed, large S of t, of an object P with displacement small s of t is changing, we need to use a sign test. If the signs of v of t and a of t are the same, either they are both positive or both negative, then the speed of P is increasing. If the signs of v of t and a of t are opposite, then the speed of P is decreasing.
Functions. The displacement function, you take the derivative of that makes the velocity. The derivative of the velocity function is the acceleration?
Here are some phrases you might see used in questions. If you are asked to find the initial conditions, remember that t is equal to 0. At the origin, the position is equal to 0. If an object is stationary, velocity is equal to 0. If an object reverses, velocity is equal to 0. If you are being asked to find the maximum or minimum displacement, velocity is equal to 0. If you are being asked to find the constant velocity, acceleration is 0. And to find the maximum or minimum velocity, acceleration is 0.